NASA is returning to the moon. With the Artemis campaign, humans will, for the first time, explore some of the moon's oldest terrain, the lunar South Pole. Untouched by human hands, this region of the moon will pose new challenges for the astronauts and offer scientists a different and exciting landscape to make new discoveries. But lunar exploration is difficult and complicated work. It takes practice. So how does one practice exploring the moon? One way is to conduct analog field tests, working in locations that mimic the conditions of the extreme environment you want to explore. This is JETT, the Joint Extravehicular Activity and Human Surface Mobility Test Team. This group of astronauts, engineers, scientists, and technicians unite to conduct their largest and most sophisticated simulation of a moon mission. The people, systems, hardware, and technology are put to the test in a training exercise for the moon and beyond. This rockyard at the Johnson Space Center in Houston, Texas, provides some rugged conditions to help train for a moon mission. It's ideal for small tests of lunar gear and exploration processes. But future Artemis missions to the moon demand full rehearsals for long traverses across a vast, desolate landscape. A greater open range is needed than can be provided by this location.
We have some great facilities located here at NASA JETT, but in order to figure out how we operate in these large expanses, going on the field is really the only way to do that.
To find the right place to spread out for a large-scale moon rehearsal, NASA has to hit the road.
This is one of our larger integrated field tests. We do smaller scale tests depending on what the nature of the objectives and the goals are. For each one, this is a big one.
This is the San Francisco Volcanic Field in northern Arizona. Barren, rugged, geologically perfect for rehearsing long walks on the moon.
Yeah, the legacy out here in the Arizona desert, it's a beautiful place to train. Apollo used it to train.
It's the right scale of exploration. So the science targets, the EVA targets, the spacewalk targets. So it gives us a robust way to test our hardware and our infrastructure in a high fidelity environment.
It's an excellent place to do this kind of research because this really vast volcanic plains has a lot of regolith on top, and so there's a lot of diversity of the kinds of clasts and materials that the crew will be seeing. And so we find that it's an excellent place for us to do our precursor geologic mapping, as well as planning traverses and having the crew be out here.
A campsite is set up. Cones are laid out to represent a lunar lander, the starting point for the journey. There are 4 EVAs, or extravehicular activities, to rehearse. Some are in the day, and some at night. Part of this test is recreating the unique lighting conditions of the lunar South Pole, where Artemis astronauts will be exploring. The lighting will be unlike any NASA has experienced on the moon before.
Apollo, we had all this great imagery and this photography and videos because it was bright the whole time. So we landed on the side of the moon that was lit the entire time during each Apollo mission. Now we're going to the South Pole.
Yeah, just because they're going to a region where the sunlight is so low, the angle of the sun is, so the sun is just going to hover over the horizon, basically. Everything is going to create really long shadows, right? And so navigation is going to be really tricky. There's going to be a really stark contrast between like the bright white rocks and like the dark shadows, right? And so that's, I think, is going to be really hard.
In these lighting conditions, scientists hope to make new discoveries on the moon regarding the presence of water, as well as elements preserved in the permanently shadowed areas of the lunar South Pole. What they find can help solve some mysteries about the formation of the moon and the solar system itself. Simulating the lighting is not the only challenge. Testing the tools, technology, and processes for lunar EVAs requires a diverse team.
The thing that excites me most about these analogs is the integration of people, right? So we have scientists out here, we have engineers out here, we have operations specialists, and just that integration where we learn each other's discipline. Like as a scientist, I learn about the suit and what it's capable of. And then the engineers and operations people learn from a scientist of like what we really want to collect. And, and so that's the part that I love about these analog missions the most, is the integration of the different teams and disciplines and learning from each other.
During the EVAs, the astronauts collect rock samples as they would on the moon. This requires stooping, using tools for grabbing, scooping, and sometimes chipping off small samples from a boulder. During this work, mock spacesuits are worn to get the right feel for these tasks.
It looks like the real spacesuit and it has all these kinds of motion restrictions like the real spacesuit. And they're pretty heavy. They're a lot of weight to move around. And they've got restrictions on the joint angles. So, we can't just walk around like we're in shirt sleeves. We're going to account for this really big bulk of the lunar suit.
You have all of these tools that you need to do. You need to understand, okay, once I start walking, how do I stabilize myself? How do I push the cart? How do I take pictures while I walk? And then when I get to the station, how am I going to take the chisel out and the hammer without falling over? And then the order of operations, do I take out my sample marker first? Do I take out the hammer first? How do I choreograph all of these motions? So the more times we do these actual analog missions, the better we get at being very efficient. That's very important for the time in the mission.
So the data that I will be collecting specifically on the suit team is related to the crew members themselves and how they're feeling and working in the suit. So we want to be able to provide them with their optimal task performance. So if I can provide them any additional comfort or mobility in the suit specifically to better perform their tasks, that's the kind of information that I'm looking for.
During their traverses, the astronauts are not alone. Back in Houston, a team is closely monitoring the activity in the Arizona desert. Just as if it were a real moon mission, this test is under the watchful eye of Mission Control.
And so that has like the flight controllers, the flight directors, and then all of the scientists, all the geologists that are going to be helping out with our actual Artemis mission.
Mission Control itself has a back room. This is the SIR, the Science Evaluation Room.
What the science backroom or science evaluation room for Artemis is actually the brain trust of lunar scientists and geologists. And their job is to feed insights and recommendations up to the crew during a mission to make sure that those objectives are represented and accomplished throughout the mission. So it's really kind of where the lunar science magic happens within the flight control team and within Mission Control back on Earth.
The science team is testing the processes of how they will work with the astronauts and Mission Control for collecting samples.
So basically, we're training the astronauts to learn how to describe the samples and to look at the samples and telling us what they're seeing, rather than interpreting what they're seeing, right? That's the science room, and the scientists in that science room can do that. But we want the astronauts to just be really good at describing of what they're seeing and describing what the rock looks like, and textures, minerals, or other rock fragments that they're seeing.
So on the outside of my sample, it's light brown, showing bits of gray on the inside. It's got a nice light gray matrix. I don't see any crystalline structure.
As the EVAs continue and more samples are gathered, the larger processes devised for lunar exploration are put to the test.
What we're trying to do is understand, how do scientists work together as a team? How do we communicate with the broader flight control team? How do they communicate with us? And how do we as collectively communicate with astronauts on the surface of the moon?
The Apollo missions taught us to expect the unexpected.
There is orange soil. Hey, it is! I can see it from here. It's orange. Look at the size of that biggie. It is a biggie, isn't it?
For this test, the Artemis team also rehearses making changes in the mission.
If we decide on EVA 1 that we want to go to a different place, or our traverse rate is different than we expected, or there's an amazing rock feature over here that we didn't know about when we landed, we will probably change our EVA plan to accommodate whatever we see on the ground.
So Andre, I think we should just go like a little bit more directly west and then head north so that we're not going through the big boulder field.
As the test winds down, the team learns what worked and what didn't work. In the end, the lessons learned will help create a template for future exploration.
These analog missions are so important for what we're doing on the moon because we need to kind of go through a dress rehearsal of what we're going to do on the moon. We need to understand the concept of operations. We also need to train every subsystem and every organization so that we can become one large team.
It's critical to test the hardware, like the geology sampling tools, in these high-fidelity analog environments. But it's also really important to prepare the ground teams, the flight control team, and specifically the science team for what it's going to be like to actually be conducting these science operations on the lunar surface.
Suit engineers, tools engineers, geologists, other scientists, human factor scientists, flight controllers. The part I enjoy the most is integrating all those aspects together to make something look like an actual lunar surface mission.
So it's just been absolutely incredible. It's beautiful, it's welcoming, and it's been an amazing place to see our team come together and work for these Artemis missions.
I love that there's no monotony in this job, and we get to do things that we've never done before, and I think that's really amazing.
It's the coolest job in the world.